All right, I guess that's my cue from Kelly to begin the introduction. Welcome everyone to the Strategic Initiatives webinar series, and specifically the Endemic and Invasive Pests and Diseases Strategic Initiative. My name is Jim Farrar, and I am the Director of UC-IPM and also the Strategic Initiative Leader for Endemic and Invasive Pests and Diseases. Today, we're very fortunate to have a presentation by David Haviland on mating disruption in nut crops. David is the Entomology and Pest Management Advisor in Kern County, and he's been with UC and UC-IPM for almost 20 years. David has a wealth of experience in invasive or exotic pests, having worked on glassy-winged sharpshooter, Gill's mealybug, spotted-winged Drosophila, and vine mealybug. He also has a lot of experience on endemic or indigenous pests like spider mites, navel orangeworm, which I'll talk about today, ants, thrips. David's been prolific in his career. He has given more than 800 presentations and more than 400 publications, including 29 peer-reviewed journal articles and another 44 peer-reviewed publications with A&R. But when asked what his favorite part of the job is, he talks about interactions with growers and the impact that those interactions have. Today, David's presentation, he's going to talk about work on mating disruption in almond, which is now over 1 million acres in California. And this has been part of a team effort, which I'm sure he'll acknowledge during his presentation. I will say that this work has gained awards from Department of Pesticide Regulation, the Entomology Society of America, Western Extension Directors Association, and the International Integrated Pest Management Symposium. And I think that Kelly has already indicated that we're going to take questions in the Q&A feature. And you can use the chat, but please put the questions in Q&A so that we can keep track of where they are. So with that, take it away, David.
Well, great. Well, thank you for that introduction. Let me bring my screen up here. So yeah, so today I get the privilege of being the narrator for this story. And that's kind of what I want to do is approach this a sort of non-technical approach to what we've done in a story mode. And this story is going to be one about navel orangeworm in almonds. And like all good stories, of course, you got to set up the setting for this book or for this story. For those of you not familiar with almonds, Jim alluded to it quickly there, but almonds are currently California's #1 crop by acreage. They're the #1 California ag export. They're the second most valuable crop by value, second only to grapes. They are, across the entire United States, the #1 exported specialty crop. In California, we've got about 7,600 growers or farmers. And when you add up what those farmers do, there's more than 100 million almond trees in California. They make about 2.5 billion pounds of almonds each year, worth about $6 billion. And I don't know how to, there's nothing more I can say. I just can't even fathom those numbers. I'm sure there's some kind of statistic that says, if you took every almond end on end and made a straight line, it would go around the moon 20 times. I'm sure there's some kind of statistic out there. I'm sorry I don't have that. But just to say, this is huge. This is a major economic contributor in California, not just in what it produces, but in the people that work, in the people that eat the nut crops, and so on. And so, in this story, of course, like all good stories, there's an antagonist. And I'll pretend we're at a stage theater, one of those fun interactive theaters. The antagonist is navel orangeworm. Boo, right? I can hear all of you on this webinar booing in the background. Because it's deserved. Navel orangeworm is a formidable enemy for nut crop growers. And it's not just almonds, which will be the focus of my talk, but also pistachios and walnuts. And this particular pest, it feeds exclusively on the kernels, which is what you're trying to sell. but also introduces fungi into the nuts that can cause aflatoxins. And aflatoxins are dangerous to people, and it's very strictly regulated to make sure that that they're not present in nuts that are sold. Just a little bit of sort of back of the napkin math I did the other day. I'm going to estimate there's about $380 million a year spent in control efforts between pesticides and sanitation. And despite that, growers still lose somewhere around $60 million a year in quality losses. So again, I'm a math person. I love doing math. If you make some assumptions and do the math, I'm going to estimate that every year about 15 billion almond kernels are eaten by navel orangeworm. That to me justifies navel orangeworm as a significant antagonist in our story. That's a lot of nuts. So, who are the protagonists? So it's a lot of people, and that is the team that I'll be talking about today. I'll start that off by saying it's campus-based scientists. I'm not really going to talk about that part of it. That to me is sort of the prequel. That's the book that we all should have already read, and that's decades of work. Decades of work figuring out what a pheromone is, how to identify pheromones, figuring out what they are, figuring out how to release them in fields, how to mass produce them. Lots of that work behind the scenes before the team I'm going to talk about today really got going. So I just want to acknowledge them as sort of the core university basic research foundation of everything we've done. And then as far as the what I'll talk about today, the team is really UCA&R and UCIPM academics, myself and the Southern Valley, but also Jalindra Rajal and Emily Sims as the sort of IPM components. So that's the Southern Valley, Central San Joaquin, and North and Sacramento Valleys. But also a large number of pomology advisors were involved in helping with research sites, but also publishing newsletters, hosting meetings, and so on. But this was, I would call a UC-led effort, but not a UC alone effort. The Almond Board has been very involved from start to finish, lots of growers and PCAs involved, industry people involved. That's people that make traps, people that make pheromone products, and so on that have been integral to this project. And then of course, funding organizations. In addition to the Almond Board, Department of Pesticide Regulation was very crucial in this project. So all the things I'm going to talk about are things that were done by this team, which, if I were to list everyone's names, would be dozens of people easily, plus all the cooperators and end users. So in this story, what is the conflict? And to set that up, I want to describe a little bit the status quo of navel orangeworm management by saying that it's just, we've got IPM programs, but they're just not quite adequate. Winter sanitation is the core of it, but especially with COVID, labor has become very difficult to find to do it. And particularly with what's going on with labor costs in California, it's becoming cost prohibitive. So, the number one non-chemical program that people use to control this is becoming less and less available during, with just the current climate in California. Another part of that's timely harvest, but you can only shake a tree when it's ready. There's only so early that you can go to try and get the nuts off the tree before damage occurs. And then as a result, what else is there? There's insecticides, but there's only really 3 options available. Some of those, like pyrethroids, have environmental concerns when they can get in waterways, toxicity to aquatic organisms, for example. Some of those products kill natural enemies. They can kill beneficial insects. So, they can kill bees if they're not used properly. So there's some baggage there. And these products over time are becoming less effective. There is resistance that's documented. And I'll tell you, there's nothing coming down the pipeline. From a regulatory standpoint, when it comes to pesticides, there's a lot of new biopesticides and things they're just fine if you're trying to control, aphids or soft-bodied insects. But when you're trying to kill these just big, robust insects that spend most of their life inside of a kernel, inside of a hull, and inside of a shell protected, that requires what you might call big guns in terms of insecticides. And those big guns just aren't being registered anymore. So it's a difficult situation for growers as far as where can we go from here. So who's the hero in our story? The hero is really mating disruption. And mating disruption is a technique where you disrupt the mating of the insects. A little bit about the birds and the bees talk here. The way it works with naval orangeworm is you get female moths. They come out of the pupa and they're receptive. They want to mate. That's their first and foremost priority. So they have a behavior called calling, where they release a pheromone to attract males. And then the males, when they come out of the pupa, they are pre-programmed for one thing as adults, and that is to mate. So they use that pheromone to find where the female is. So what we do is we take a pheromone, it's been identified, mass produced, and you release that out of the orchard where you make a complete plume or cloud of pheromone throughout the orchard. And this does two things. So first of all, if you're a male trying to use the pheromone to fly to a female and find her location, if the entire orchard smells like a female, you can't find where she is. You get lost in the process. You spend a lot of energy and she doesn't get mated. The other thing it does is it gives what I'll call the males a headache. And to understand this, I think everybody at some point in their life has stepped into an elevator with, just really nice old lady that's wearing way too much perfume. And, when you do that, you get one or two just, whiffs of that really strong perfume smell, and you instantly get that sinus headache. It just kind of wigs you out and you just want to find fresh air. Well, that's what happens to males. The receptors on their antennae are very, very, they're very receptive. They're very sensitive. And so when you flood the orchard with pheromone, these receptors just fire and fire, give these males a headache. And even if they try to fly to find a female, they can't find her. So essentially, instead of trying to kill naval orangeworm, we are solving the problem by making sure that they never get born in the first place. That's a pretty innovative approach. And fortunately, it works pretty darn well. On top of that, this approach, safe for humans, pheromone has no impact on us, safe for the environment, it doesn't affect bees, it doesn't get in waterways, it's not a traditional pesticide. So a lot of perks to it from that standpoint also. So moving to the middle chapters of this book, unfortunately, books can't just have a first chapter and a last, right? There needs to be something in the middle. So really quickly, chapter 1 with any pest management project is the does it work question. And yes, it does. And we've done a lot of work on that. On the top right, for example, is just a typical plot map we use for this kind of trial. But just to point out in these particular trials, you can't just spray a tree. You have to make a plume of pheromone with the moths that fly around. So that little plot map up there that has those little squares, for example, that little blue square you see, that little blue square is 4,000 trees. So when you consider that one square is 4,000 and you start adding up all those little squares, really quickly you realize that most of these trials we're doing, have 60, 70,000, 80 trees in them. So this is big work being done on commercial scale in growers' fields. And in this case, fortunately for us, the work showed that not only is there one product that works, but there's products from 4 different companies that are all equally effective. And that's awesome because then we don't have to go out and pick favorites, and say who somebody should use. We can say there's 4 options. They're all similar. You can shop around and that's great for extension. The next chapter is what I'll call the consistency of results chapter. So, if you're a grower, you would much rather have a product that works that provides 50% control 100% of the time, instead of having a product that provides 100% control 50% of the time. Okay? That way you know exactly what you're buying. And to help out and answer that question and to gain that confidence, 12 demonstration sites in 4 different counties, 2 different years. These demonstration sites weren't just UC led, but they were put together by a committee of us, USDA, growers, PCAs, to figure out exactly what we wanted to demonstrate and what was the most value to demonstrate in these growers' fields. That dictated what we did. And as a result, we've got very robust data that this technology works, that we can go out and sell it, if you will, to the industry. And along with that sales job, the next chapter is the P&L sheets, the costs and benefits, which are extremely important for adoption. and frankly is a weakness in a lot of university research. There's a lot of trials out there that show that something works or can work. But if someone says, so what does it cost? It's common for the researchers to say, I don't know, the products got donated. So that's something we wanted to overcome, and we did. And just to show you the kind of data we've got once the numbers were crunched, in this sort of column you can see here in the middle, we can go to meetings and say, if you're a grower and you didn't use main disruption, in hindsight, if you had less than 1% damage, good on you. Your investment in main disruption wouldn't have paid off. If you've got 1% damage, or that's what you had without main disruption, had you used main disruption, you would have broken even. Whereas if you had more than 1% damage, you would have made money if you had invested in a main disruption system. And by the way, average damage in the state is around 1%. So that simple statement by default is saying more than half the people, they were either at the average or above the average, if they didn't use main disruption, would have made more money had they used it. That's a pretty compelling argument when you're trying to describe this kind of technology that's new. The other thing is we crunched the numbers with if you did mating disruption. And this has been really valuable because a common thing we get at meetings is someone will come up inevitably and say, I used main disruption, I got 2% damage, it didn't work. Well, we can turn around and say, I was gonna say, are you an idiot? We don't actually say things that way, but we literally have the data to say, like, are you kidding me? If you used main disruption and had 2%, all the data says if you hadn't used it, you would have had 4. And the difference between 4% and 2% is hundreds of dollars per acre when mating disruption only costs you 100. So please don't go out and say it didn't work because you got 2%. Go out and be glad you used it because you would have lost hundreds of dollars per acre had you not invested. So lots and lots of fun having this arsenal of the economic data. And then the last chapter here in the middle of this book, of course, is information delivery. It's great to have good info or write a good book, but if nobody reads it, it's not worth much. And in this case, with the people I described in this team, in the last 5 years or so, this team has given more than 150 presentations, 36 different cities and counting, 20 different counties, more than 20,000 people have gone to those talks. We've also done more than 50 extension publications. Some of these are, a lot of these are main disruptions. Some of these are also other IPM topics in Almonds that were also done simultaneously with these projects. So not all of these talks and publications are main disruption, but they're all integrated pest management in Almonds, many of which were main disruption. And then things like demonstration videos. In fact, we just finished some recently that the Almond Board sponsored. They were produced professionally to talk about main disruption and show how it can work to growers. So lots and lots of efforts. Well, so what's the last chapter of the story? Let's flip forward to the last chapter. I'll call this the climax or resolution chapter. A&R leaders will probably want me to call it impacts, so I'll put that in parentheses up there. But what have we seen as a result of these efforts? For the last 5 years, every single year, we've seen an increase in adoption. So 5 for 5, that's not only good data, but that's a good trend. We've seen adoption not only by almond growers, but also by pistachio growers and walnut growers. So there's some translatability across these nut crops. Currently, our best estimates are that there's about 400,000 acres of nut crops using main disruption. It's not an exact number just because no company wants to tell you their exact sales. It's competitive out there, but that's a pretty good estimate. And if you do the math, so that's about 45 million trees that are currently under main disruption. Again, if you do the math, I like math. I would estimate there's about 5 million pounds of kernels saved every year. If you assume an average yield and that main disruption in those orchards gets you from 1 to 0.5% damage. And again, doing the math, that's about 1.7 billion kernels every year that get eaten by people instead of by worms. That's my favorite impact. So on top of that, there's no added cost to growers because we've really showed that what you get back economically covers the costs. if not more than covering the costs. And all this is with a technology that's green, it's sustainable, it's not, traditional pesticide, just lots and lots of perks. So, very, very pleased with the outcomes of this particular project and what it contributes to overall, A&R mission. As you know, A&R has got a lot of, has 5 strategic initiatives, one of which is the focus of this series. But within those, there's several public values that, that consistently we're trying to achieve. And in this case, regarding economic prosperity, we're helping growers to be more economically, to make more money. We're also helping growers to produce crops at as low a price as possible, which helps people be able to afford almonds. And if you help people buy food, you're helping their personal economics. So it's not just a field thing, but it's every Californian that buys almonds. We're developing a qualified workforce. We're helping these farmers and pest control advisors know how to manage navel orangeworm effectively. We're helping them produce abundant and healthy food source. Almonds are a very healthy food, very common snack food. Also a very high source of protein, which is valuable. We're helping protect natural resources by using reduced risk, sustainable alternatives to traditional pesticides. And as far as healthy people and communities, and tying that back to protecting natural resources, a lot of us in California, we think about our California-centric world. But if you start looking overseas, particularly in Asian countries, where do those countries get their protein from? Primarily through fish or through soy type products. And, if you're inland from a coast near fisheries that are being overfished with products like fish that only last a few days unless you dry them, every almond that we export is a little packet of protein that has a long shelf life anywhere in the world. So we're not just helping people be healthy here in the US, but also overseas where these nuts are exported. And then as far as goals of having an inclusive and equitable approach to things, the number of extension activities, where they're done, how we've done them, the publications, where we've put them. I want to compliment this team for an incredible job at helping make sure that everybody has access to the information that we've developed and disseminated. The fact that 400,000 acres are being used attests to the fact that we're reaching every corner of the industry in every way possible so that adoption can be universal. So with that, thank you so much for the opportunity to highlight this project. I know it's just one project within what A&R does, but glad to be able to highlight what we're doing within A&R to help make sure that there's a positive impact and benefit to all Californians. So thank you.
Thanks, David, for that really great story. We're going to go to questions, and Shauna has a question. Are worm populations substantially reduced in subsequent years after use of mating disruption?
So that's a good question. So there's a lot of historical data from mating disruption systems that says yes. Some of those go back to research on codling moth and walnuts in the Delta, 20, 30 years ago. So yes, there is a carryover effect. At the same time, in almonds, the carryover effect is not quite as substantial in other crops. And that's because of the way sanitation works. So, after harvest, you'll have, let's say, 100 nuts left in the tree. And you come in and you shake the trees, you windrow the nuts, you destroy those nuts. So in the process, you're removing 99+% of all of those nuts in the winter that represent the carryover population from one year to the next. So yes, there is a carryover from one year to the next, a longer term benefit, but I would have to say that impact is probably fairly small compared to the impact of what winter sanitation does to affect one population carrying over to the next. Now, as growers do less and less winter sanitation, as it gets more and more cost prohibitive, I think what the carryover effect is going to become more and more important as we go forward in the future.
All right, great, thanks. So I'll follow up with a question since I don't see any new questions in Q&A. there's a long history of mating disruption. You mentioned for codling moth in apples and other plum fruits. Now, mating disruption in almonds and other nut crops in California. What other crops and pests do you think are ripe for this technology?
Wow. Yeah. So that's a difficult one because not all pheromones are created equal. Well, first of all, not all insects have pheromones. So obviously we just ruled out the majority of the universe, right? So you have to work with a system exclusively that has a pheromone, but it also has to be a pheromone that can be synthesized, and one that can be synthesized cheap. You know, if it costs hundreds of dollars per acre to produce a pheromone, it's just not practical. And then pheromones are complicated. You know, in some cases, a pheromone might be 7 or 8 different chemicals involved at once, where there's one of those that really drives the system. And there's other cases where it takes 5 or 6 of those in the right combination to actually attract or disrupt a moth. So when it's all put together, this isn't a technique that can just be used anytime, anywhere with the right science. It is going to be limited. Generally speaking, it's limited to worms. And so the most common systems right now, in addition to naval orangeworm, are codling moth, oriental fruit moth. There are systems for peach twig borer, not used a whole lot, but there's other things like carob moth down in the Coachella Valley, in palm trees, and the neck it's used in Australia, where carob moth is their main pest in almonds. Oriental fruit moth, very common in stone fruits to use mating disruption. And then outside of that group, there's also some hemipterans. So vine mealybug, for example, there's some new mating disruption systems there that are very effective. Pheromones have been identified for other mealybug species, but at this point, haven't gotten to the synthesized cost effectiveness to actually have mating disruption programs. So, and then there's other interesting work. So, for example, aphids produce alarm pheromones. It's not mating disruption, but there are other uses of pheromones. So if you can do an alarm pheromone, maybe you can scare something away and make it not want to land. We're also doing work, for example, with bees. So bees use a sort of pheromone to identify places that have good flowers. So if you take those, if you take those pheromones, we're actually doing work with this with a splat program, where if you take those pheromones and you spray it on an almond tree or on a blueberry field, it essentially smells like a place that bees say is a good place to collect pollen, which makes it additionally attractive to bees, especially in a crop like blueberries, where honeybees are used for pollination, but blueberries technically are buzz pollinated, which is by bumblebees. So we're essentially tricking honeybees to want to pollinate a crop that's supposed to be pollinated by bumblebees. So, so the whole pheromone thing, in the wider universe, there's a lot of very, very creative things that are being done. Different ways to release pheromones. We've got your aerosol dispensers, there's static dispensers, there's sprayable formulations being made, splat formulations. We've done work applying them by drones to see how that would work. It didn't work. That's why I didn't mention that in this story. Nevertheless, that kind of work's being done. So lots of very, very interesting work. And the other cool thing is there's a lot of funding out there right now for alternatives to chlorpyrifos types of, alternatives to pesticides, green solutions, sustainability. There's a lot of money out there for this kind of research for anyone that's, that's listening, that's interested in getting into that area. It is sort of the new frontier and a way forward with some pretty innovative research. It's pretty exciting. Spray and count trials, they're great. They're bread and butter. We do them, but pretty exciting to get out there on the leading edge, and UC is doing that with lots of projects in addition to the one that I've described.
All right. Thanks, David. I don't see any additional questions in the Q&A, and we're running up against the end of our time. So I'll just close by saying thank you so much for sharing this story with us. I think it's a really excellent example of A&R's work in the state, developing innovative solutions and really moving the needle on our public value statements. So thanks, David. And in about a month, we have another one of these with Whitney Brim DeForest, who will talk about weedy rice in rice production. Talk about a real difficult challenge. Thank you all for attending today, and have a great rest of your day.
Thank you.